And I clearly don't know how to pause. Oh, there's the pause button. Now I'm learning. So there is a pause button on the Screencastify when I get distracted. Okay, so notice your function is increasing. If you have an increasing curve, your left endpoint will always be an underestimate, and your right endpoint will always be an overestimate. If you have a function that is a decreasing curve, we can just look at it like this, then your left endpoint is always going to be an overestimate or an upper sum, and your right endpoint will always be the lower of the two. So you just have to know whether or not your function is increasing or decreasing on your interval, and you will know right away whether or not you're looking for an underestimate or a lower estimate of your Riemann sum. Okay, so left endpoint, right endpoint, I feel like we pretty much have those ones down. The next one is midpoint. And a midpoint approximation is actually not the sum of the two endpoints, for the very simple reason that in order to get the midpoint, we actually need to calculate the midpoint. The halfway point between 1 and 2 is 1.5. Between 2 and 3, 2.5, 3.5, 4.5, and so on. If we just add up the values, the square root of 1 plus the square root of 2, and divide that in 2, that's not going to get us the value at 1.5. But that calculation we did before is important, and it does have a space, which I will show you. So midpoint is still something we have to calculate, and I haven't seen this one very often at all in the AP exam, but it's still good to know to do. We still have our 1, and the only difference is you're going to multiply by those values. So we're going to use each midpoint of each one of those intervals. Now, it's going to get us a better approximation than a left endpoint and a right endpoint. You'll see it falls somewhere in between. So still a better one. And then the last one is going to be your trapezoid. Again, often called a trapezoidal sum. All right. So what it looks like using areas of the trapezoids. We're going to actually use both endpoints because now each endpoint is going to represent base 1 and base 2. So if we go back to, again, this picture. So base 1 will be f of 1, base 2 will be f of 2, and again, our width is still going to be that difference between those two, which is going to be 1. So this one's going to look like, in terms of a formula, you still have your 1 for your width. But now you're taking, and we're going to add up base 1 plus base 2 and cut that one in half. So 2 and 3, cut that one in half. I'm wondering if I'm going to run out of space to put all this in. And we keep going until we get our last two bases and heights. So your trapezoidal sum is actually, if you look at the way it's working, this is really the average of your left endpoint and right endpoint approximations, not the midpoint. So when this gets all nice and calculated, I'm running out of my paper space, that gets us another approximation. And notice that's a little bit closer to your midpoint. Both trapezoidal and midpoint are much better approximations than your left and your right. However, sometimes you got to use what you were asked to use or ask what you're given. Okay, so that's a nice summary of all the Riemann sums. Next video is going to show us how we apply this to tables and what type of questionnaires that you're going to be able to see on your AP exam.